Hey guys, welcome back to the home shop. We're down here today because we've got a flame spray repair job to get done. This is part of a variable speed pulley off of a jet milling machine. And this belongs to, I believe his name is pronounced Taras or Taras. I got it written down right here, and you can find him on Instagram under @Tarmec with the underscore there. So I'll have it up on screen so you guys can check him out. He's got a cool Instagram page. He's into all the heavy industrial tools, you know, the big vices and the shop cranes and machine work and stuff like that. So he's been a follower of mine for quite a while. Seems like a pretty cool guy. And he reached out to me recently asking me if I would be interested in helping him repair this step pulley for his milling machine. Because otherwise, if he can't get this repaired, he was going to have to buy another one. So it is a replaceable component based off of what he said, but of course he was trying to get this done pretty quickly. So I had a little window of opportunity here, so I told him to get it down here, and we'll see about getting fixed up. A couple of little challenges that we have ahead of us here for doing this flame spray. One is the shoulder where this bearing, it's a bad bearing fit. I think I forgot to mention that. So this is the bearing, and that's what's the problem is. He's got a spun bearing fit on this journal right here. And if I drop that down on there, you can see it's got a lot of wear. It's got somewhere between like 15 and 20 thousandths wear depending on where you measure it with the calipers. So not a good fit at all right there. Okay, so one of the challenges is you can see the shoulder for the bearing actually goes back past this face right here. So it's not like you can just come in here with a tool and turn it to that shoulder. You'll have to kind of come in at an angle, put an angular tool in here to kind of get in there and do the cuts, as well as the undercut and the threading that we got to do here as well. So that's one of the challenges. The other one is how thin that is. It's a pretty thin bore that we're dealing with right here. So whenever you're using the torch, the flame spray, you have to be real careful not to get this too hot, because as you probably know, the thinner the material, the easier it is to heat something up. You don't want to get it too hot and overheat it. So whenever we're spraying this, what you're going to see me do is I'll come down, I'll make a pass or two, or make a pass and come back and lift off. That way the flame isn't constantly on this part getting it too hot. That's how you have to do that. You just got to come down, put a little bit, come off, let it cool for a few seconds, come down, spray it again until you get your buildup. I'm going to be doing a minimum undercut on this to try to minimize how much buildup we have to do on that. But all we're going to need is 15, 20 thousandths undercut, and that'll be good right there. So it is I believe this was 50 millimeter journal size. Yeah, so 50 millimeter, and then the bore is 44. Yeah, it's a 44 millimeter bore. Just filling you guys in on that. And roller bearing here, I went ahead and looked up the tolerance in my book on the fit. So I'm working an inch. So this is inch dimensions. That's going to be your minimum and maximum of what we want to turn this to whenever we finish it. So that's going to give you what, 4/10 tolerance to fall within, so that this has a proper fit on that journal right there. All right, should be able to hit that, to me no problem. Now he did say that he was going to send a fixture or a jig that he already made to hold this, and this would probably work. He's got this piece of aluminum that goes up in there, then he's just got a bolt and some washers to come down and pull it up tight against that. Now this isn't quite up to my A-bomb standards of how I want to hold this thing to get the job done. This kind of throws a little bit out of balance with those washers there. Certainly it'll get it done, but this is not how I want to do it. So I've actually taken a piece of stock and machined a fixture that this pulley will fit on. It's still in the lathe because I did not want to take it out after I turned it, and it's going to fit nice, just like that one there. And I've also got a heavy washer that I machined that's going to fit in here. It's going to center up on the bore, and then we'll have a stud coming out and a flange nut to pull this thing up. So we'll stick it on there, tighten it up, and it should be good to go. So we'll go on down to the lathe and start getting this guy set up. I did want to show you this. This was a gift that he had sent me as well. So pretty cool. Adams Tool and Engineering Incorporated out of Lansing, Michigan. He says that this was a plaque that was mounted to the wall there for this company, and he had acquired it and wanted me to have it. So pretty cool sign. This is it's cast aluminum. So a pretty cool sign that we'll have in our collection and probably put it on the wall somewhere. So thank you for that. So this is the simple fixture that we machined. It's just a piece of 2-inch cold rolled, 1018 cold roll. Chuck it up, turn it, that way it stays nice and true. And I fit it nicely to this 44 millimeter bore here, okay? I'll show you, so we get on there. And there's a little bit of, a slight amount of warpage on this end of this pulley, so it gets tighter as it gets on there, which is actually a good thing for this, help keep it true. So as we get on there, we have to just kind of spin it up to the shoulder there. And then I took another piece of stock and just machined a nice heavy washer that fits the end of that board nicely, just like that. Then we'll take a 1/2-inch stud, screw it all the way in there, and then take a flange nut and pull it up tight. So there's your flange nut. And that way, it's nice and centered and pretty well balanced too. And it won't take much to hold it, so we'll just tighten it like that and it should be good to go. So we'll crank her up. Now you can see the stud and the nut isn't perfectly true, but that's not a big deal. What we're worried about is this journal right there. But since our bore, we're centered up on that bore as perfectly as we can get, that's where we want to turn this journal to. So whenever it's all finished, both the ID and the OD are perfectly true to each other. And just eyeballing the flange right there, I mean, it looks, I really can't see any run out. If there is maybe 1 or 2 thousandths. So it should be good to go. So I plan on, I'm going to go ahead and coat all of this here with some masking compound so that when I'm spraying, I'm going to have to spray at an angle to get in here on it. So I don't want it to stick to this area up in here. We should be able to just take our Scotch-Brite and clean that off after we're finished with that. All right, so we'll go ahead and get it masked and start getting it undercut. Always got to make sure your parts are clean of oil. I like using this CRC Super Degreaser Plus. It's non-chlorinated, so it doesn't have a flash point. Just spray it on there and then blow dry it off, and it should get rid of any of the oils on there. All right, and then so our masking is going to be the Eutectic Solution 103. I show that because every time I make a video on this, I have people asking, so that's what we're using, Solution 103. You just paint it on, just like if you were painting anything. That's about the consistency of it right there. And I'm going to start right about here. Work my way out. We're not going to be building up the whole thing, by the way. We're just doing, I believe it was about an 18 millimeter area, but there's a slight step in there that the factory machined to, you know, for the fit. And we'll just match that. That way the bearing kind of slips on and then it goes into its proper fit. All right, so we'll put this up in here. Like I said, we'll Scotch-Brite this off whenever the job is done. Put a little bit in there on that shoulder. That's going to be getting the brunt of the spray right there on that shoulder there. All right, and we're just going to let that dry, and then I'll get the undercutting done. A little tip for getting this stuff to dry pretty quickly without burning up your oxy fuel. Just use one of these Burns-O-Matic torches. And this will help dry this masking compound out a lot quicker without having to ignite the torch over here on it. So here's where all those old high-speed steel tool bits come into play, or if you can grind your own tool bit, which is what I would have done if I couldn't find one. But I've got a couple of tool bits right here that's going to serve my needs perfectly. These are very old high-speed tool bits. This is the Simmons brand. We've got one right there, and you see one side's got a radius ground on there for cutting a corner radius, and then you've got what looks like a you know, for cutting a snap ring groove or some kind of groove in an OD, but it's ground so that you can get up next to a shoulder or get up in there. And that's exactly how this tool will work. It'll get all the way to that shoulder with this tool holder right here without getting into this face right there, okay? But I actually found a couple of them pretty well identical. So this one actually has a threading tool ground on one end, and the other side is the same as this. It's like a grooving tool, all right? But this one here is a little bit thinner, and what I've done is I've honed a couple corner radiuses on there, and I'm just going to use this tool here to turn it to get the undercut done. I'll take this one out, and then this one, since it's such a fine point on there, I'll use this one to machine the little thread, the undercut there, the fine pitch undercut. So I wanted to point that out, that it's nice having all of these old tools that were ground by either my dad or my granddad or any of the other machinists before me that filled these toolboxes up with all these tool bits. They do come in handy for job shop work, just like this right here. All right, so we're gonna use this guy right there. I think this is gonna work pretty good. Put that one back in there and we'll get our undercut done. All right, we're gonna get our undercut done. So because we're using high speed, we do wanna run kind of a slow RPM on this so we don't burn that tip up. I got it set at 120 RPM. I'm gonna come right out here, almost to where that little step begins. All right, there's our touch off. So let me go ahead and zero it out right here. You can see it's not running very true. So we'll start with 10 thousandths. Feed it across. Now we're getting into all the wear where the bearing actually sits. Just move it across by hand. And I want to get I've got a 0 point set where I think it needs to be, which is right there, okay? We'll come back and make another pass and get this all cleaned up. So that tool worked out pretty good. I took a total to clean that up, 25 thousandths on the dial. So you're looking at about 12, 13 thousandths per side that we have gone into that right there. So I'm glad that's all it was, because I didn't want to take any more than that. I'm going to go ahead and take this tool out, and we're going to put in our other tool that looks just like it, but it's got the threading tip, because I do need to scratch a thread across this. That is the proper way to machine the seat in order to accept the flame spray, the powder, as it comes in. So I'm just going to square it up. It looks like it's pretty good there. Might have to tweak it just a bit. Looking against his face right there. Yeah, we'll need to tweak it just a little bit, square it up. I had to pull the camera back up out of the way a little bit. I'm just going to do it just like this. All right, that should be pretty good. All right, and we'll set it to a fine pitch somewhere around, I usually use around 22 to 24 threads per inch. Make one little scratch pass across there, and then we'll be ready for spraying. Okay, so we're using our Eutectic Teradyne 2000 flame spray torch, and then we're going to be using the 21022 powder to build this up. This is my go-to powder for all of these general applications like this. Spray a little bit, come off so you don't overheat it. That should be good to go. So our part is cool, completely cooled down to the touch. I've got my tool set up here so we can get in here at the angle to machine this. So I'll show you what we got there using my Armstrong tool holder. Micro 100 carbide tool bit. This is a style D tool. I've already honed it nicely. So it's got a nice sharp edge, and I've got everything positioned now on the tool post, the tool right here, so that we can come all the way in here to our square shoulder and be able to cut this and have clearance on the side of the tool, have clearance on both sides there so you're not going to rub. So we are ready to turn this down. Let's give it a shot. All right, just trying to touch off on your high spot right there, and then we'll make a light cut across here to try to get a diameter established. Alrighty. Got a diameter established now. Let's knock the dust off of it. And we'll get a measurement on here just to kind of see where we're at. Okay, 2 inches, 8 thousandths. So we still got a little ways to go. About 40 thousandths to bring it down to size. So we'll keep making our light passes across here till we get it down there where we need it. So getting in here to measure this is a little bit of a challenge too, and I've gone through a couple of my micrometers, like this Brown and Sharp right here. This is one of my favorite 1 to 2 mics to use. The problem is right here where you got to measure it, the closest you can get in here, so it's hitting this part of the mic here. So you just got to make sure you're squared up nice. So I moved over to my granddad's Shure Tomiko. And because this is a little bit smaller in diameter here, it's allowed me to kind of get in there and be sure that I'm kind of squared up nicely. I can feel it on the measurement just like you should. And I'm clear up here too. All right, and I'm just using that one. So one of those things where you don't really think about it, but sometimes having a couple options on different tools really helps you be able to get in somewhere and measure it. So we've still got, I'm down to my last 10 thousandths to turn this down. So I'm going to keep working at this. And because this one's going to be a little more tricky to try to polish, you know, than a standard journal on a shaft, I want to try to make sure I get this one turned in right where I want it on the high side of the tolerance, so that maybe all we have to do is just kind of hit it with some Scotch-Brite to kind of polish it up and finish it out. It's looking good. It's starting to finish out nicely. Alrighty. 60, 70, 73. 973 where we're at. So I'm shooting for a 1.9693 as our max diameter there. So I'll make a second measurement just to be sure that I'm getting the same thing, and we'll finish it out. Yep, 973. This should be our finished pass on here. Trying to sneak up on that max size there, so whenever I finish this cut, I'm not gonna retract the tool. I'm just gonna back it out in Z, because I may have to take another half dowel or so. All right, blow it off there, and then you still got to kind of wipe it with your fingertip, because that you can still feel dust that's just kind of stuck to the surface there. And let's get in here and get a measurement. Got to be careful not, when you pull it off, to rub the barrel there of the mic because it'll rotate it. So that's going to put us at 969.5. So I'm 0.2 over what our max should be. So I'm going to go back in here. This is what I was thinking was going to happen. I'm going to go back in here. I'm just going to ever so slightly make a movement on the cross slide here. Let's see if we can get a couple of tenths out of this. But since we're shooting for the high side of the tolerance, that should still put us in a good position there to finish it out. You can hit it with that Scotch-Brite and it'll take off at least a tenth, maybe 2. Do the same thing. I'm just going to back the tool away. Yeah. It's got a nice finish on it. Let's see what we did now. Okay. Bam, we hit it right there. We're exactly on our max of 1.969.3. So that makes me feel good right there. So we're just going to leave, I'm sorry, we're not going to leave it. We're just going to leave it. We're going to leave it where it's at. We're not going to turn it anymore. But I still have this little area in front of it that I need to kind of clean up and make this look a little bit nicer. This is because this is an undercut here up to your journal. So we want to clean this up a little bit right here with our tool. And then we can start cleaning everything up. The rest of this in here should just knock right off there because of your masking compound. Yeah, knock that stuff off nicely. Just have to hit this with some Scotch-Brite to remove the mask. This guy is all finished up. I've mic'd it twice just to be sure we're on size, and we are exactly where we need to be for our max tolerance. So we'll go ahead and take this thing back apart. No damage to our bore whatsoever with the flame spray buildup. That turned out nice. Okay guys, so we've got our pulley half all finished up and I think everything turned out nice. We got it all cleaned up, you know, using the wire brush to help kind of knock that masking off there. It does really stick well. So wire brush it and then just hit it with the Scotch-Brite to kind of bring that nice luster back to the bare metal state. I did not touch that side right there. There's no reason to. This is a nice smooth side that the belt rides on, so I didn't want to mess with that. But our repaired side looks good. Our finish on our flame spray buildup turned out excellent, and it should be on a great size on our max tolerance allowed for this roller bearing right here. So you can slide this down on there, and you can see that it's got some resistance going on, which is what it should have. Just a few tenths difference between this and that journal right there. So ideal way to install this bearing would obviously be to warm it up. I don't know if Taras has a bearing heater, or you can even come in here with a very, very small flame and gently warm the ID of this this bearing race. And if you do that right without overheating the bearing, that should warm it up just enough where this would actually just drop right into place. But if that's not an option either, you can definitely go to the press and press this in, but you just have to be careful that you only press on the inner race right there. So you got to take like a piece of tubing, machine it so that it fits just over this right here and is only touching on that race, and then you should be able to just very gently press it down on there. All right. So another example of how the Eutectic flame spray system really is beneficial to a job shop in doing repairs that are otherwise maybe much more difficult to repair, or even parts that you may not be able to repair. You got such a thin wall on there, especially with these internal keyways in there. You got such a thin wall that if you come in here and try to weld this, or maybe even try to braze it up, you've got such a thin material that the heat may damage it. You may break through or melt it. Not saying that it can't be done. It's a little more challenging doing it those other ways there. So this is the Eutectic is such a beneficial way to repair components, I think, and I really enjoyed doing it. So this worked out really good. Should put him back in order, and he can get his jet milling machine back together. This is his main machine that he used. I think it's his only mill. So he was worried about it being down, and whenever he messaged me, he asked if it was possible if I could kind of expedite this repair and get it pushed through quickly so he could get his mill back in operation. And that's exactly what I've done, is got it done quickly, and we're going to get it packaged up and send it back up to him. So hopefully that's going to fix him up good. Again, to Raj, thank you again for the cool sign. That is really neat. So something fun that we can hang on the wall. And that's it. Hope you guys enjoyed the video, and we'll see you again on the next project.